Hi, welcome to our next level 3 differentiation video. In this video we don't have any examples to go through, but we have some important notes, important information, important ideas that you need to know about calculus at this level, and it'll be great to go through these and maybe take notes if you need to. Right, some of the things you will know, some of these things you may not know by now. First thing, a maximum and minimum turning points are points on the curve which have a zero gradient. Remember, a maximum occurs when the gradient changes from a positive gradient into negative, and a minimum occurs when the gradient changes from a negative gradient into a positive. And both of them have a gradient rule equal to 0. Alright, a function is increasing if the y value becomes larger as x becomes larger, i.e. the function goes upwards from left to right. And you can see on the function below, there are two parts of the graph where the function is increasing. A function is decreasing if the y value becomes smaller as x becomes larger, i.e. the function goes downwards from left to right, and you can see it's this middle section where the function's decreasing. When the function's increasing, it has a positive gradient, i.e. y dash, the gradient rule, is greater than 0. And when the function is decreasing, it has a negative gradient, i.e. y dash, the gradient rule, is less than 0. Alright, let's introduce this word, concavity. Concavity is a word that describes the direction of bending for a function. For the graph on the left, this is called concave from above. Try and think of it as if you were flying above and you look down, it looks like a cave from above. And this function is called concave from below. And again, think of it as walking along the ground and looking up to see the cave above you. Right, well, here's a function. Here's the maximum point and minimum point. In this section, the graph is concave from below. The cave is looking out down from below. In this section, this is concave from above. The cave is looking from above. It's at this point we call it a point of inflection. And a point of inflection is where the function changes in concavity. Right, let's have a look at this crazy looking function. This has got a rule y equal to x cubed. If we take this side of the function, we could say that it's concave from below, although we don't see it all in the graph. And if we take this section of the graph, this part is concave from above. So we go from a positive gradient to 0 gradient back to positive gradient. So this point here is still a point of inflection because it changes in concavity, but notice what's going on. In the graph on the left, we have a point of inflection. In the graph on the right, we have a point of inflection where the concavity changes, but the graph on the right, the point of inflection has a gradient of 0. So the point of inflection can have a gradient of 0, but not always. Right, stationary point. Stationary point is a point on the function that has a 0 gradient. These could be maximum points, minimum points, or sometimes a point of inflection. Not all point of inflections have a 0 gradient. This one over here does not have a 0 gradient. Great, thanks for watching.